welcome back. We're going to do a little painting today. I hope that it is a wonderful day where you are. It's a fantastic day here, and I'm glad that you could join us again for a little astronomy. Today we're going to be doing a very special type of landscape that's one of my favorites, and I hope that you really enjoy it too. So, as usual, we're going to scroll our color palette along the bottom, but for you to keep up, we have our Alizarin Crimson, our bright red, we have our yellow ochre, we have our Prussian Blue, can't forget old phthalo blue, and what would it be astronomy without a little midnight black? So let's use this midnight black first and just kind of lay a baseline of our background and what we're going to see here. We'll draw first our abscissa. We have our abscissa, or the x-axis, and then we have our ordinate. We have our y-axis right here. And we just kind of let those flow, let those happen, kind of nice straight lines here. And then we'll put a little bit of color mark here. First we'll let old Alizarin Crimson sit here. Got a little bright red in there. Just kind of let those colors hit the whiteboard and just let them be happy little strokes with the pen. Got a little Prussian blue right in here. Just let it land. It doesn't really matter. We're just making a little index for our graph that we're going to draw. Good old phthalo blue down here on the end. All right, now we've kind of got our color marks here, and that's what we've got for our x-axis. And these represent our spectral classes. And we have our O, B, A, F, G, K, and M. Now these spectral classes were laid out by Annie Jump Cannon, and she had such a happy little way to remember them. O, be a fine girl, kiss me. Now wouldn't that just make you happy to have a girl kiss you, make a little smooch? All right, well, especially if you're a lonely old astronomer at your telescope all night. But let's remember that, oh, be a fine girl, kiss me. Those are just your little spectral classes. They're just your spectral classes for your stars. And then on this axis, we have our absolute magnitude, or your luminosity. Luminosity. Wouldn't that be a great place to live if that was a city? That'd be like luminosity. That'd be like the brightest city that there is. It'd be like heaven. All right, so now we know what our axes are like. Let's see what we got to do here. We're going to drop in a few stars on our graph. We're going to just put a few down here. You can make them dots. You can make them happy little X's. It doesn't matter. It's okay. They're just data points, and you're just going to put some data points down here at the bottom. Now let's move on to a little bit of bright red. Let's put some more bright red stars up in here. We're going to put those there. Just drop them in. They follow a little pattern here. Just make a little happy trail. We're going to make a trail through the deep dark forest. You know, I'm going to skip ahead and do a little bit of phthalo blue, because I know phthalo blue likes to live up here. That's where his house is. He's got a house way up here in the sky, phthalo blue. We're just going to drop in some stars up there. And then a little bit lighter, a little bit more laid back is his friend Prussian Blue. Phthalo is like to keep to himself, but Prussian Blue kind of likes to come join the party. So he's going to come down here. And now, right where our sun lives, right in here, just a little yellow ochre. A little bit yellow ochre, just drop the points in. They can be dashes, they can be points, they can be X's. Just make sure and put them in your chart so you know what they are. Just indicate them on your index. All right, so we've dropped some of those in, and let's not forget about some of our other just little stray dogs that like to float around up here a little bit on this asymptote. And then finally our big red giants. Our nice red giants, they like to hang out up here. Just some happy little stars. And then last but not least, we can't forget our cute little baby white dwarfs. Just drop them in. Just put a few dots here, a few dots there for your data points. And hey, let's just put a few of them over here. Those will turn out not to be the real points. Those are just outliers. Just a few happy little outliers. All right, now what have we got here? We've got a nice little happy trail that starts down here at the deep dark red, and then it moves on up to a little bit brighter red into the yellows. And wouldn't you know, our own little happy our sun is right in here with the G's. The sun is a G2V star. And that's its spectral class, and that's where it lives. And it's about medium on the luminosity scale. These other little red stars, they're dim little stars, but they're happy to just shine where they are. And they're way down here on luminosity. And then your big, bold stars, like Sirius and Rigel and some of your nice, bright white stars, they live up here with the phthalo blue. They're your big, bright stars on the luminosity scale. And then you also have some really bright stars, but they're hiding out in the reds. We call those your super giants. Imagine giants living off in the forest all by themselves. Got your super giants. Those are your stars like Betelgeuse or Aldebaran or some of the nice bright red ones. And then down here in this little pocket, you have some really special stars, your little white dwarf stars. Not the same kind of dwarf that used to live with Tycho Brahe. That was a different kind of dwarf, but this is a dwarf of white dwarf stars. And we know from Dr. Chandrasekhar that there's a limit to how big those can be, up to 1.4 times the solar mass. Anyway, we have our stars, and we've graphed them by spectral type, and we've put them up on the axis of luminosity. And you know what we've got here? We've got our beautiful Hertzsprung-Russell diagram. And we call it the HR diagram for short, but this really stands for two people. It's Idner Hertzsprung and Dr. Henry Norris Russell. And they both came up with the same idea around the same time, so we like to give them both credit. They're both great astronomers, so we like to give them both credit. But really, it was Mr. Hertzsprung, Idner, Danish, I believe, and he came up with the idea first, but Henry Norris Russell mostly popularized it. Now, it was kind of funny, but Mr. Hertzsprung liked to have his abscissa where the ordinate goes. He used to draw this whole chart flipped one side to the other, and his rationale was, well, this is your x-axis, and the x is the thing that you should measure, and the y should be the function of it. And so when we're looking at stars, we're really measuring the luminosity of the stars and plotting their color by luminosity. So he liked to put his the thing that you measured being the absolute magnitude of the luminosity on the x-axis. But anyway, Henry Norris Russell liked to put his axis this way, and he kind of popularized it a little bit more, and so we just put it this way. It doesn't really matter. You can have one or the other on the axis, but this is the way that you see it most often. So as you travel through on your journey through astronomy, I hope that you really enjoy your Hertzsprung-Russell diagram. And remember, our happy little star is just, our sun is just living right here in the middle of all of his little friends. And we got some happy little K-type stars and some F-type stars, but we're just right here, just a normal run-of-the-mill star, right in the middle of the main sequence on the Hertzsprung-Russell diagram. So thank you for joining us again. I'm Bob Astross, and I hope that you had a really good time where you live. I hope it's beautiful, and always remember to keep on astronomizing.